2.2 part 2. So what about this one? X equals y squared. This time we're going to pick some y values and solve for x. So x is equal to negative 2 squared, which is 4. X is equal to negative 1 squared, which is 1. 0 squared, which is 0. 1 squared, which is 1. And 2 squared, which is 4. So let's graph those. We have 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. So is this a function? It is not a function because of the vertical line test, or you could even look here and see that these x's repeat with different y's. What's the domain? Remember, domain will be all the x coordinates. So the domain is going to be 0 to infinity. And how about the range? The range is going this direction and this direction. So the range is actually going to be all real numbers. You can write it that way or this way. So determine whether x equals negative y squared is a function, graph it, and state the domain and range. We're working this one the same way. X equals negative of negative 2 squared. So we have negative 4. Then we have negative of negative 1 squared. So we get negative 1. Negative of 0 squared, that's just 0. Negative of 1 squared will be negative 1. And negative of 2 squared will be negative 4. So we have negative 4, negative 2, negative 1, negative 1, 0, 0, negative 1, 1, and negative 4, 2. So this graph looks something like that. Is it a function? No. And what's the domain? The domain is going to be everything this direction. The range is going up and it's going down. So for the domain, we're going to get negative infinity to 0. For the range, we're going to get all real numbers. So how about this one? Determine whether y equals the cube root of x is a function, graph it, and state the domain and range. So we're going to have y equals the cube root of negative 8. Well, let's think about that for a second. Negative 8 is going to be negative 2 times 4, right? Oops, that should just be one line. That's negative 2. Now we want to have a group of 3, so we're going to need some more negatives. First of all, is this true? Is negative 2 times negative 2 times negative 2 equal to negative 8? It is. So all of these get to escape, but remember only one survives. So the cube root of negative 8 is negative 2. How about the cube root of negative 1? That's just negative 1. How about the cube root of 0? And the cube root of 1? And the cube root of 8 is 2. So plot these points. We get negative 8, way out here somewhere, negative 2. We get negative 1, 0, 0, 1, 1, and 8, 2, way out here somewhere. So this makes this crazy S-shaped looking thing. Is it a function? Yes. What's the domain of this function? It's going forever this way. It's going forever this way. So the domain is all real numbers. What's the range? The range is going this way and this way. So the range is also all real numbers. What about putting a negative in front of that function? What would happen if you did that? So we have y is equal to negative cube root of negative 8. Well, the cube root of negative 8 is negative 2. So we have a negative of a negative 2, which is 2. The negative cube root of negative 1 is a negative of a negative 1, or 1. And the negative cube root of 0 is just 0. The negative cube root of 1 is negative 1. And the negative cube root of 8 is negative 2. Okay, we plot these. Negative 8, 2. Negative 1, 1. 0, 0. 1, negative 1. And 8, negative 2. What's the domain? It's going both directions. The range also going both directions, just like on the previous page, except the graph is switched. It's reflected over the x-axis. So what about semicircles? Do you remember that this is the equation of a circle? So whenever you have a semicircle, one of your variables is squared and it's under a square root, and the other variable is just singular. So let's look at these three coordinates. So we have negative square root of 4 minus negative 2 squared is 4. So we have the negative square root of 0, which is just 0. Okay, so what if we go back and put a 0 in the place of those x's? So we put a 0 here. 0 squared is 0. 4 minus 0 is 4. So the negative square root of 4 will be negative 2. Okay, so what if we were to put a 2 in there? Two squared is 4. 4 minus 4 is 0. Square root of 0 is 0. So we have negative 2, 0, 0, negative 2, and 2, 0. Remember, this is a semicircle, so it looks something like that. Is it a function? Well, I actually told you that it was, right? This is a function. A circle would not be, but a semicircle would be. What's the domain of this particular semicircle? The domain actually starts at negative 2, stops at 2. It does not continue past those points. So for the domain, you would say it is negative 2 to 2. And how about the range? The range starts at negative 2 and stops at 0. So for the range, you would say it is negative 2 to 0. Here's just another one. Let's see what it looks like. So we have y equals the square root of 9 minus negative 3 squared. Negative 3 squared is 9. 9 minus 9 is 0, and the square root of 0 is 0. But what happens when we put a 3 in there? This just becomes positive. 3 squared is also 9. 9 minus 9 is 0. So when you put 3 in there, you also get 0. But what if you put 0 in there? 9 minus 0 squared. That's going to be the square root of 9, which is 3. So we have negative 3, 0, 0, 3, and 3, 0. Again, we have a semicircle. What's the domain? And what's the range? So the domain is going to be negative 3 to 3, and the range is going to be 0 to 3.